Now that we've covered the basics of defining and calling functions in Python, let's turn our attention towards using functions to improve the design of our programs. Good design of programs is about many things. It includes optimizing properties like correctness, efficiency, and maintainability. Here we'll discuss using functions to improve the readability of our code, which can support all of these properties. Having well-readable code means relying less on your internal understanding for that code and relying more on the organization, the conventions, and the design written into the code itself. This means keeping our functions well documented by including things like docstrings, which describe the inputs, outputs, and purpose of that function. It also means keeping our functions focused on solving singular tasks and limited to comprehensible sizes. As an example, consider this mystery function. What does this function do? It's not immediately obvious. Now, this function is relatively simple compared to some of the functions you'll eventually create, but even still it's difficult to understand without being properly documented. We could try running this code. But when we run it, we get this nondescript prompt asking us to type some things. You can see there's an input in the code with that prompt there. So we could just type in some numbers maybe. Again, looking through the code, I can see if I use the word quit, that should stop this. And that seems to do it. As an end user to this experience, though, that wasn't super obvious. We got the number 12, and it's not super clear what that means either. We could try running the function again, and maybe enter some words, and those just crash it. So without proper conventions, the purpose of this function is fairly unclear. So we can look through this mystery function a little bit to see perhaps if we can understand it just on a line-by-line basis. So the very first line says y equals 0, and we enter a loop. So we've initialized a variable, we have an infinite loop, and it says x gets some sort of user input, checks if that input is equal to quit, and if so, then we break out of our loop, so that exits our loop. So we're repeatedly asking the user for something. The next line says assume what we've gotten, if it's not the word quit, is an integer, so we're asking the user for some kind of integers. The next line says if x is less than 0, then negate it, so take any negative numbers and make them positive. So any numbers the user asks, we're just going to make them positive integers. And if x mod 2 equals 0, so if the number we're given is even, then we'll add it to y, so y plus equals x. So y appears to be some sort of sum variable, collecting all the even values that the user enters, all the positive even values that the user enters. Now, it's a good idea to explain this to a user so they don't have to go through the individual lines of your code in order to understand your code, and this is the idea behind commenting your functions. So one convention for this is to use what's known as a docstring. This is just a multi-line or triple quoted string placed at the start of your function. So we say triple quote, then some docstring, and then 3 more quotes. Now, like a comment, these are ignored by Python. It's actually just a really long string that isn't used in your code, so Python sees that and doesn't do anything with it. But the humans reading your code will see this and understand your code better. Now, they won't understand your code better if you just say docstring, so it's a good idea to put useful information in here. So the information you want to include in the docstring is to describe your function to another human. So you want to clearly describe the inputs, the outputs, and the purpose of that function in 1 or 2 sentences. That way anyone using your function can know what inputs your function expects, what outputs they can expect from your function, and the general process between those two. So in this case, we can say this function repeatedly asks the user to enter positive integers. And since this is a multi-line string, we can continue on to the next line and returns the sum of the even ones. So notice this describes the input. That's the user is entering positive integers. The outputs and the process are more or less described in a single sentence here. Sum of the even ones, so we're going to sum up all of the even numbers the user enters, and that's what we're going to return, so that's our output. You can be more explicit in your docstring. You can have labeled sections for inputs, outputs, and purpose. Generally speaking, so long as your docstrings clearly describe what your function is doing and all the necessary components to use that function, then it's fine. And usually the specific format of your docstrings will be dictated by the style guide of whatever organization you're coding for. With this docstring, we have a bit of a better understanding of what this function is and what it's used for, but a user of this code still doesn't have the greatest user experience. They're just given an empty prompt. They're not told how to use that prompt or what that prompt is expecting. So let's include just a bit more description so the user knows what the instructions are for using that prompt. So we'll say, enter a number and type quit to stop. Now this will print out and they'll still get their regular prompt, but at least they now have instructions on how to use that prompt. So let's try this out again. Exit our code, rerun it. And we're just going to say, this is mystery func. Now we have an instruction, enter a number, type quit to stop. So I'll enter number -3, that's fine, 9, 7, 5, 4, and 2. So quit. And the only even numbers there are 4 and 2, and so we get 6 as a result. So looking back at our code, it's a bit cleaner now. We understand what the purpose of the function is. We have some instructions for our user input, but the code itself still doesn't have any specific comments. It doesn't describe what parts do what. Now, as this code is somewhat simple, it might not require too many comments to allow another programmer to understand it. However, the variable names here are effectively meaningless. We have the letter Y and the letter X, which they both have purposes, but neither of them are descriptive of that purpose. So it's a good idea to use meaningful variable names as a way of making your code self-documenting. So for example, the variable Y here is summing up all of the numbers. So we could say something along the lines of sum. It's technically summing up just the even numbers, so we could even say even sum. And change the variable Y everywhere we have it, even sum and even sum. Similarly, the X variable here, that's the user's input, which is some sort of number, hopefully, unless it's also the quit. So one issue is we have this variable used many times throughout our code. So it would be an arduous task to have to repeatedly change this variable name in all the places that it shows up, and it's also somewhat error-prone to do so. Thankfully, our IDE can help us with this task, so we can actually just, you can hit the F2 key or right-click and rename symbol. And I can just type in the new name. So I'm going to call this usernum. I can hit Shift-Enter and it'll tell us all the places. So this is a refactor preview. Refactor means to take one thing and change it. In this case, it's taking X and it's replacing it with usernum in all these places, which is pretty much what we expected. So we can say apply, and it does that. You can also just hit Enter from that original window and it'll just do it without the preview. And now we can see our code's a little bit more self-commenting. So even sum is 0, the usernum gets the input. If the usernum is quit, then we'll break. We'll convert the usernum. If the usernum is less than 0, then we'll make it negative. If the usernum is even, then we'll add the usernum to the even sum, and we'll return the even sum. It's a good idea to keep our functions also tailored towards a single specific purpose. For example, the print function displays a value. The input function gets a value from the user. The string function converts inputs to a string. The random.randomInt function generates a random integer. These functions all have a single specific purpose that's more or less described by the name of the function itself. Here our function is named mysteryfunc, so it's not super clear what its purpose is. We could come up with a better name though. So in this case, we've described what the purpose of our function is. It's to sum all of these even user numbers. So we could rename our function. We could say instead sum usernums. Now it's taking user numbers and summing them. That's a bit clearer. We could even say sum the even usernums. Remember, there's no limit on the length of these variable names, although having too long makes them a bit cumbersome, so it's good to have a balance between description and brevity. Now, even with a single task for our functions, sometimes the body of those functions can become quite large as those tasks become quite difficult and depend on a number of subtasks in order to accomplish the main task, in this case, summing user numbers. When we have large and sprawling functions, it can be difficult to see or to maintain those functions, as it's difficult to even contain them all on a single screen. So these functions can often be subdivided into smaller tasks to help keep everything readable. These are what are known as helper functions that handle those subtasks, so we can use those helper functions in our main function. Now, our sum even usernums function is not particularly large, but for the sake of demonstrating, let's take some of the subtasks from this and put them into their own helper functions. For example, we have this section of code here, which checks if the user's number is less than 0, and if it is, it negates it. This is effectively doing the absolute value, which itself is already a built-in function, but for the purpose of demonstrating, we can make a new function that does this part of our main function. So we could say def abs, and that takes in, say, some number x, and we'll describe it. So this function takes a number as argument and returns the positive magnitude of that number. So the size of the number, ignorant of the sign. Okay, and then the code is pretty much the same as we have, except now we have the variable x again. So if x is less than 0, then we will return negative x. So if we got a negative number as our input, then we'll have a positive number as our output. And if we had a positive number as our input, then we'll just return x. Notice we didn't need the else here. Our if statement says if x is less than 0, then we'll return negative x, which means if this is true, this branch is terminal. We'll exit the function at the end of this branch, which means anything that comes after that branch will only occur in the case where this if statement was false. We could include the else statement if we wanted. It's just a few more characters to type. So we can take this function now and use it in place of the code in our main function. So we could say something like user num equals abs user num, and that will take the existing number, pass it through. It'll become x. We'll check, is it less than 0? If it is, then we'll return the negation of that. If it's not, we'll return the number itself. And in either case, we'll store the result back in the original variable. We could even condense this code a little bit. So instead of having user num converted to an integer and then separately converted into a positive number, we could do this all on one line. So we could say abs of int of user num. So if we get past the quit, then we're assuming it's a number. So we'll convert it into an integer. We'll convert it into a positive integer, and then we'll store it back in the result. So that cleans up our code a little bit. Test it out, make sure we didn't break anything. Oh, it's not mystery func anymore. It's now sum even user nums. Run that. Our code still seems to work. We'll say 5, 6, 7, 8. 6 plus 8 is 14, so it seems to still work. So the code here is functionally identical. It's still doing the exact same operations. It's just a little bit more condensed. So our main function now has this abs call instead of the 2 or 3 lines that it represented. Again, this is a demonstration. Imagine if this function, our original function, was hundreds of lines of code long. We could take large paragraphs of that code, say 10 lines each, and put those into functions, again, assuming they have their own specific singular purpose. So to recap, we're keeping our code well documented. We're including doc strings at the top of each one of our functions that include the inputs, outputs, and purpose of that function. We're making sure that our variable names are meaningful so that their code becomes self-documenting. It's a good idea to include regular comments as well wherever needed. So in this case, we could say, check if the number is even. So common comments like that are still valid. We're also making sure our functions have meaningful names and reasonable sizes. Notice the function that we have now includes a lot more English words and a lot fewer math-looking symbols. So all this works together to make our code more easily digestible by humans.